Hi everyone, welcome to Google Cloud on Air. My name is Jay Jenkins and I'll be your host over the next 4 days covering 12 sessions. Thank you so much for joining us. Please remember that at any time you can ask a question below and we have technical experts standing by ready to answer. In this session, Malcolm Holden's going to kick it off for us by letting us know everything you want to know about Google Cloud Platform to get started. So with that, I'm going to transfer to Australia, so bear with us a few seconds and hold on to your headphones while we go.
Thanks, Jay, and good morning, everyone. As Jay mentioned, my name is Malcolm Holden, and I'm a customer engineer based out of the Sydney office for Google Australia. Today, I have the pleasure of having the first session within the OnAir webinar series to introduce the Google Cloud Platform. A little later on, I'll be joined by Hilary and Liam, or perhaps just Liam, I think, to address some of the questions and answers or the questions that you've raised during today's webinar. So the goal of this morning's webinar is really to introduce you to the components and the services that make up the Google Cloud Platform. It's not my intention to make you an expert. It would take a lot longer than 40 minutes to do that, but really to go through what's available on the platform, from infrastructure through data, from collaboration to machine learning, everything in between, and to give you a feel for how you might be able to use it in your own organizations and in your own workloads. But before I do that, I'm going to take a little bit of a step back in time and talk about perhaps some of Google's history. So in the beginning, about 18 years ago, Google started with a vision to organize the world's information and make it universally accessible and useful. And to that end, we have Google Search. And you're probably all very familiar with this interface, as it's been ingrained in our day-to-day lives over the last many years, actually. But along the way, from our starting point to where we are today, we've had a lot of challenges to address internally to bring search to the world. So we've had to work out technology on how to crawl the internet, bring in all that data, understand that data, organize that data to a point where we can serve that data back out to the users around the globe. And that's taken a bit of a challenge for us. We've invented or built and established infrastructure, networking topologies, and software stacks to help us. And it's those capabilities that we now provide to the world as a Google Cloud Platform. So search has expanded over the last 18 years. In the year 2000, a billion was a big number. A billion probably still is a big number. But today, we're providing search to over 1 billion users. But it's not just search. There are many other products within the Google family that also serve up capabilities to over 1 billion users. And you can see some of them represented on this slide. So Google Search, of course, Google Play, Google Chrome, Android and YouTube, and Google Maps, Gmail, and of course Google Cloud Platform, which has over 1 billion users today. And along the way, as I said, we've established our own infrastructure, our own software services, and our own network topology to help us meet the demand of our customers, to the point where we can now serve a query against a petabyte search index under a second, in a quarter of a second or so, which is pretty cool. And it's those services that are running, as I mentioned, on our infrastructure. And it's that infrastructure that is really Google Cloud Platform. But our infrastructure is always changing. And this slide provides an insight into how we're expanding that infrastructure across the globe, and in particular in 2017. So this slide shows you where our regions are around the world. In particular, interest is all the regions that are coming up inside Japan and Asia Pacific this year. So Singapore's launched, Tokyo's launched, we've got Sydney on the radar. So our infrastructure is growing all the time. New points of presence, new regions, new zones. But it's not just the infrastructure in the countries, the points of presence, it's also the network topology. So we have one of the world's largest, if not the world's largest global network. And at any one time, it's estimated that about 1/3 of the internet traffic is running across the Google backbone. And by accessing Google Cloud Platform, you have access to our infrastructure, but also our network topology and our network to provide a low latency connections between your own applications. It's not just about infrastructure, it's not just about network. There's a whole lot of cool software services that we also provide. And if you look at this slide, you'll probably recognize some of the terms. So starting off with Google File System back in 2002, moving up through MapReduce, Dremel, Bigtable, Flume, Spanner, which has now of course been made into Cloud Spanner. But these software technologies have started as research projects within our labs, with our engineering teams, to help us address some of our problems. They've been open sourced, and these are now available through the Google Cloud Platform as well. So when you sign up to Google Cloud Platform, you get access to Google's infrastructure, Google's network topology, and some really great software that's going to help your business thrive. Typically when people talk about the Google Cloud Platform, or if you've had a presentation by perhaps some of the local teams, you would have seen this big slide of blue hexagons with strange icons on them, roughly divided up into things like compute and management tools and big data. When you look at this, it can be a little bit overwhelming, and indeed when you go to the Google Cloud website, it can be a little bit overwhelming as well. So each one of these, and in fact there's a lot more capabilities within the platform than what's shown on this slide, but each one of these capabilities would take perhaps an hour, a day, a week to become really familiar with. So my intention is to not address everything on this slide, but to break it up into some logical chunks that as a person starting out or as an organization starting out on the Google Cloud Platform, it will make that journey or that on-ramp a little bit easier. So the way I'm going to do that is really covering the things you see on the screen here. So I'm going to start by talking about computing. I'm going to move into some of the networking services that make your life easier or help your journey to the cloud. I'm going to talk about storage, big data, administration, development, and because it's Google, we're going to talk about machine learning as well right at the end. Now, some of these individual topics are going to be addressed later in the week through their own OnAir webinars, so I may not drill down into too much detail on some of them because they'll be covered later in the week. But my goal, as I said today, is to give you an introduction, make you feel comfortable with some of the terms we're talking about, so you can start cementing in your own mind how you might be able to use them inside your own organizations. So to start with, computing, or perhaps more simply, how do I do things on Google Cloud Platform? So the first way we can do things on Google Cloud Platform is using virtual machines. So virtual machines are basically, I have something running, I have it running in my own data center, I have it running somewhere else, but I want to run it on Google Cloud. How do I do that? And then we move into the second option we have for doing stuff on Google Cloud, and that's really around using containers. So containers are a very popular way of abstracting development into applications, into containers and managing those. And I'll talk a little bit about how we do containers on Google Cloud Platform as well. As I mentioned, there's a separate webinar later in the week to talk about some of these. One of them is container technology. And then finally, we'll abstract that a little bit further and talk about serverless computing, which is a bit of a buzz at the moment. Very closely aligned to platform as a service, perhaps just, it is platform as a service essentially under the covers, but how do I abstract my development, my workloads down to that layer where I'm not really worried about managing the infrastructure under the covers. I'm not worried about, I don't want to manage the infrastructure, I don't want to manage the operating systems, etc. I want to abstract that up, so all I worry about is my application itself or the functions running within that application. So to start with, virtual machines. They're pretty straightforward. It's serviced in the Google Cloud Platform by a thing called Google Compute Engine. You can elect to create an engine or create a server, a virtual machine with a range of CPUs, a range of memory assigned to that. So 1 to 64 processors, 0.6 to 416 gigabytes of RAM associated with that. There is a bit of a ratio between RAM and CPU, which is mentioned here as well. And then there are disk limits around that. So I can add persistent disk, I can add some solid state drive, I can add RAM disk to my compute engines. I can pick one of the application operating systems that are available in compute engines. So I could run Debian, Ubuntu, Red Hat, or Windows, or I could bring my own. If I wanted to run a different flavor of Linux, perhaps I could bring along that distribution and install it on compute engine. I could start with a base Debian or Ubuntu image, make changes to it, save it as a template, and then use that internally as my own template moving forward. So that's virtual machines. The good thing about virtual machines on Google Cloud is they run up in tens of seconds. So, sometimes it's 10 seconds, sometimes it's 20, but it's in that kind of order of magnitude. They're very quick to start, very quick to run, and within a few seconds, you're in there actually at the prompt doing what you need to do on your own virtual machine. Sometimes though, you want to kind of jumpstart that. And there's a capability provided in the Google Cloud Platform called Cloud Launcher. And Cloud Launcher is a library of typical server patterns and software deployments that help you kickstart. So for instance, I might want to run up a LAMP server or a WordPress server or a Drupal server or a Jenkins server. Then there are patterns in the Google Launcher that you can use to kickstart that. And it's as if you've built your own compute engine, you put your software on it, and you're ready to go. So it really kind of jump starts you into that. There's patterns in the launcher for individual systems, as I mentioned, or groups of servers working together. So it's worth looking at those patterns and the capabilities provided in Cloud Launcher to see if they will jumpstart your journey to the cloud. So I may not do a demonstration today. I thought I might, but I think I might just keep going. The second way we can do things in Google Cloud is using containers. So if you've been around for a little while, you'll know that containers are essentially Docker-based abstractions, so down to an application level that I deploy into a container-type engine. From a Google Cloud Platform perspective, this capability is addressed by Google Container Engine, which is essentially managed Kubernetes, which of course leads to the question, as one of our developer advocates in the US calls Kubernetes. What exactly is Kubernetes? So Kubernetes is essentially a container orchestration system. It's an open source product that, as I mentioned, came out of our labs, and it allows you to run a large number of containers and orchestrate them to remove complexity and assist with managing and monitoring those. So as an example, if I have multiple systems here, I might be running a single database, I might be running 4 different API layers or 4 different servers at an API level, maybe a web front end, but I want to treat them as a complete system. So with Kubernetes, I can define what the components are, how they should be orchestrated, and Kubernetes looks after the management of that. So that if one of my API servers goes down, it will automatically start a new one for me, right? So it's around making things simpler. So Kubernetes, of course, is open source. You can download it from GitHub, and you can start building it wherever you wanted to be perfectly honest. So you can run Kubernetes on premise, not just inside Google Cloud Platform. But to do that, you would have to build out the infrastructure on premise or wherever you're doing it, install the OS, install the software you need, put Kubernetes on each one of those instances, tie them together perhaps with a network topology. Then you may want to also install a DNS server, a service discovery application, some monitoring and logging. So there's quite a bit of work there to do it if you're doing it in your own premise or somewhere else. From a Google Cloud perspective, it's quite simple. So within the Google Container Engine, all you really need to do is to log on to the Google Cloud Platform console, go into Container Engine, and hit a little blue button, say Create Container Cluster. And because Google Container Engine is a completely managed version of Kubernetes, we look after the rest. So it enables you to focus on your containers and how they should work together. So it removes a lot of complexity there. So Google Container Engine, I mentioned it's managed Kubernetes, so containers as a service. We include some defaults around monitoring and logging, DNS and service discovery, and this can auto-scale based on parameters that you set up. So if you need to scale a particular layer or a particular service within that container instance, it will scale accordingly. Now, the other way we can do containers in the Google Cloud Platform is using a capability called App Engine Flexible. Not App Engine Standard, but App Engine Flexible. Essentially, this is it's a way of running Docker containers under the covers. And typically, we lock the App Engine Flexible down, or we include a number of runtimes for App Engine Flexible. But if you go into the settings and you switch a setting that says runtime equals custom, you can bring your own Docker container and run it up inside App Engine Flexible as well. And that provides you with some great capabilities. It means you can access the rest of the services within the Google Cloud Platform stack, but it also gives you auto-scaling. It'll give you a single endpoint for using the service, and it will auto-scale from one to whatever you need based on your load. So 2 ways we can do containers within the Google Cloud Platform. And there's a session later in the week, as I mentioned, on deciding which way is best for your organisation, and I encourage you to tune into that one a little bit later. There are a couple of tools available to help you with containers within GCP. The first one's the container registry, which is essentially a registry for your Docker images. It enables you to take your image, your Docker image, upload it to the registry, where you can then deploy it to a production, in a production way into the Google Cloud Platform, or you can actually bring it down and work on it on your own workstations inside Docker. So from a development lifecycle, this is a really great tool that enables your developers to store Docker images up in the registry, bring them down, work on them locally. Once they've got them working locally, put them back up the registry, and then deploy into production, etc. And this works with both GKE, and GKE is the short term for Google Container Engine. Think of it as Google Kubernetes Engine, perhaps, App Engine Flexible, and Docker. The other tool that's available there is Container Builder, and this is a tool that enables you to, once you start building out more complex container-based systems, and you need a way of perhaps tying those together and pushing that through a continuous integration type scenario, Container Builder helps with that. So it enables you to define how those containers work together, etc., and then push them out. So the other way of abstracting this out is using, I've mentioned App Engine Flexible. So we can run App Engine Flexible using that, runtime equals custom and bring your own Docker image, or you can run App Engine Flexible as a serverless type way, in which case we provide a number of, runtimes depending on the language you want to actually develop in. And then you basically go at it and you write your application in one of those languages, and you can deploy an App Engine Flexible. What it does also enable, so App Engine Flexible enables you to extend beyond just the capabilities of those runtimes. So what do I mean by that? So in PHP, you might be using PHP to develop an application, but you want to include some C libraries, you want to bring those in. You can do that within App Engine Flexible. App Engine Standard, however, does not provide that. It's a bit more constrained, a bit more locked down. And by doing that, we are able to scale it a lot more quickly than we can scale an App Engine Flexible runtime. So we can scale App Engine Standard deployments from 0 instances up to whatever you need. App Engine Flexible goes from 1 to whatever you need, so there's a little bit of a difference there. But both of these provide a way of abstracting your development to focus on an application. So you're no longer worried about managing the infrastructure or the operating environment. We're just worried about developing our application and deploying it. And of course, the last one here is a new capability called Cloud Functions. So if App Engine was about abstracting to the application level, Cloud Functions is about abstracting to a function level. So rather than writing a complete application, I'm writing a discrete function that I'm deploying. Cloud Functions will provide an endpoint, so you can hook that into the systems that need to call that function and provide responses to events. So I guess an example here is if I have an application and within that application I want to add the capability to send an email, rather than building that capability inside the application, I might create a Cloud Function that just sends the email, and from my own application I just trigger off the endpoint, fire off the packet, and it looks after the rest. So that's containers in a nutshell. So App Engine Flexible, App Engine Standard, and Cloud Functions all provide that serverless type platform as a service ability. So that's computing and getting things done. We've got virtual machines, we've got containers, and we've got serverless around App Engine and Cloud Functions. And then we come down to networking. So how do I connect my various compute engine instances perhaps with my on-premise systems or other compute engine instances or other databases, etc. That's where networking comes into play. So there's really 3 elements here as well. So we want to be able to connect, we want to be able to secure, and we want to make it highly available, make those connections available across. And there's a session later in the week, I think, about securing workloads, so they're going to probably talk a little bit more about networking security, but at a high level. So connecting, there's a couple of ways we can connect. So Google Virtual Network, exactly as it says, it enables us to create a private network for our instances within GCP, and we can set up custom routes to non-Google locations as well. So it's a way of creating that a virtual private network within Google Cloud. So Google Cloud Virtual Network. Similarly, if you've got large amounts of data, or you're using a lot of Google services and you want a fast way of connecting your on-prem or your location to Google Cloud Interconnect provides that. Essentially, it's a dedicated connection from your computing infrastructure into ours and enables you to get that data across the network very quickly. Of course, once it's inside Google, you can make use of the Google network topology, low latency network around the globe. So from a security perspective, a couple of things here. So virtual private network, VPN, this is not a service that's directed at individual users that may be out traveling the world and they want a secure way back into the corporate. This is about setting up virtual private networks between compute instances, if you like, between gateways. It essentially can use any IPsec compliant gateway, and now you can construct that just as you would VPN network anywhere else. Similarly, firewalls. So firewall, it's a firewall. You set up rules, you set up routes. You can apply those rules to tags and to hosts and deploy them, and we'll look after enforcing those rules for you in your network and across your instances. So then the question comes up, what happens if I've got something a little bit different? So non-managed security solutions. Well, you know what? You can just spin up a compute engine instance and build it by hand and incorporate into your overall schema. So some things there you can do around that. Or you could go back to Cloud Launcher, look at some of the patterns that are available there, things like Barracuda, Cloudflare, etc., and use those as a starting point. So there are options there available if you can't find anything within the platform to address your needs. So availability, content delivery network, this is about pushing data out to the edge of our network. So things like edge caching, preload of data. So it helps you deliver content to your end users in a much more performant way. DNS, so this is our managed DNS within the Google Cloud infrastructure. The SLA here promises 100% uptime. I think it's one of the only services that does that in the Google Cloud platform. But essentially, it's a DNS server, right? You can store one, you can build one up in the Google Cloud platform and use it to serve your addresses. And then, of course, load balancers, both internal and external, to distribute load at a web front end or between components of a solution. So storage. There's another session later this week on storing data in Google Cloud, but essentially it's worth, there are a number of options here. So the first one, think about files, think about object storage or blobs, perhaps, unstructured data. So this is images, Word documents, spreadsheets, whatever it may be. I want to store them somewhere. Then I have a range of database options. I want to store some more relational type databases or perhaps some NoSQL databases data up there as well. And of course, then we have big data. So we're looking at file storage. We have a number of options there depending on what you need. So multi-region is where we distribute data and store it in multiple regions across the Google Cloud network. Regional within a single region, but split across zones, and then nearline or cold line. So it really depends on what your exact requirements are, depending on which way we go. Then I'll talk a bit through those. It's worthwhile thinking about, when you're looking at storage concepts, thinking about the type of data. Is my data going to be publicly available? Is it processed data? Is it data that I brought into my network and I need it to be close to my own processing applications? Or is it that long-term storage data? So it's an archive or it's a backup type library that I want to store. And if I understand the type of data I'm working with, that can help me determine which way or what the best solution there to store within the cloud platform I should store my data in. So publicly available data, perhaps I'm going to store it multi-region, geo-redundant, high availability, and it comes with a storage cost of about 0.026 cents US a gigabyte per month. Process data, so this is data that perhaps I want to keep local, keep somewhere close to my applications, and stored within a region. So a narrow geographical region within country, if you like, but split across zones, so I do have some redundancy there. And then longer term storage. So this is data that perhaps I don't need every day. It would be great if I'm storing a long video file and I want to put it somewhere where I've got it available, but I don't want to pay a premium price for it. So it's a lower cost to store, but there's a retrieval cost associated with it. So look at your data requirements and then try and map those to the type of services provided. And as I mentioned, there's a webinar later this week to talk in more detail at the storage capabilities. So application data, this is where you start getting into that religious debate. Should I store it in a SQL database? Should I store it in a NoSQL database? What's best? And I'm not going to tell you what's best. It really comes down to what you want to use for your own application. But we have both. So from an SQL perspective, we have a service called Cloud SQL that enables you to create a traditional SQL-based server, relational database up in Google Cloud Platform. You can scale it vertically. It will manage. We do managed backups for you. At the moment, you can run MySQL or PostgreSQL up there. The other way is using Cloud Spanner from a SQL perspective. So Cloud Spanner was a recent announcement, but this provides relational database that is strongly consistent, highly available, and globally distributed. And there's a session later this week that's going to drill into the covers of Cloud Spanner and talk a little bit more about how that's possible. And then we have the NoSQL or NoSQL capabilities. So here we're talking about Cloud Data Store. It's document-based, it's indexable, and it can scale quite well. So we have a lot of organisations, storing game data, user data on this kind of database up in the cloud. And of course, Cloud Bigtable, which is a next level up, if you like. If you've heard of HBase, it's quite similar in that it provides columnar, low latency, scalable database or NoSQL database. It really, though, is for data, big data. So it's data above like a terabyte. That's when you start using Bigtable. So files, databases, and the last one, of course, is big data. So big data, where do I store my big data? Well, you can really store big data in any one of those services. So you might store it on cloud storage, you might store it in a SQL database, or you might store it on the NoSQL databases. What's more important is what you can do with that data, what you can do with that big data to enhance your analytics and get insight out of it. And to do that, there's a number of tools. Perhaps at the forefront is a capability called Google Cloud BigQuery, which is a way of piping data into a semi-structured type storage system and then enabling us to analyze it very quickly. Using SQL. So traditional SQL, you can write SQL against a BigQuery data set and get results back very fast. If you're trying to process big data on premise, typically what you do is you spin up lots of compute instances, you throw all the compute power you have at a query, you throw the query and the data at it, and hopefully you get a response back. From a Google's perspective, BigQuery, it's our infrastructure. So using BigQuery, you're able to throw all of the compute power we have allocated to BigQuery at your particular query and get a result back very fast, to the point where we're querying billions of records and we're getting responses in seconds. One of my colleagues locally likes to do a demonstration on a petabyte database or a petabyte data set with over 1 trillion rows, and he gets results back in 3 to 4 minutes. So it's a very powerful way of analysing a large amount of data and to get insight. Big data is not just about storage, of course. Perhaps getting data into and out of big data is important. So this is Cloud PubSub. It's a messaging bus. So it enables me to push data into a topic and then pull data off a topic and process accordingly. It scales very well. It will easily handle up to 1 million transactions or messages a second. It actually goes much higher than that. But if you're dealing with more than 1 million, we like you to give us a bit of a heads up. So anything up to 1 million, you're fine just to go at it. Anything over 1 million, just give us a bit of a red flag or a white flag and say, hey, we're processing quite a lot of messages here. So it does scale quite significantly. And one of the ways we often pull data out of that topic queue or process other data is using data flow, which provides a transformation layer. If you've heard of Apache Beam, data flow is our managed instance of Apache Beam on the Google Cloud Platform that enables you to take data, transform that data, augment that data, and then store that data elsewhere, perhaps in a different database, pushing into BigQuery, or whatever you need to do. And the other capability here is around Google Cloud Dataproc, which is our managed Spark and Hadoop cluster on the cloud. There's a session later this week about most of these, I think. I'm not going to drill too much into it. But essentially, it enables you to spin up your clusters for a Hadoop-type processing very quickly and enables you to do those jobs very quickly, then turn your compute resources off. So rather than building big clusters to do Hadoop processing on premise, you can use Google Dataproc to give you a managed environment, which you can spin up very quickly, do your work and turn it off. Interesting thing here is that most of the services inside Google Cloud Platform normally can be linked using PubSub or using cloud storage. So it's a way of perhaps loosely coupling these together. So of course you can use, there are APIs for all of our services and you can address them programmatically, but quite often it's a lot simpler to go through Cloud PubSub or through cloud storage. So it might be a message or an application might say, I've got a new image file to analyze. They store the image on cloud storage, which might trigger a cloud function to start doing some machine learning, use the Vision API to understand what's in the image. So it's a way of loosely coupling our services together. So what happens if you need something that's not available on Google Cloud Platform? So you can use non-managed storage systems in the same way that we can spin up a compute engine instance to do some security functions. You know, we can do the same thing here. We can build up a compute engine instance and put whatever software we need on it. Or go out once again to Cloud Launcher and look at some of the pre-built solutions that we have available. So things like Cassandra, Mongo, etc. So from an administration perspective, there's a couple of things here we want to talk about. So reporting, security, and configuration. So across the Google Cloud Platform, we have a capability called Stackdriver, and Stackdriver provides logging, not just for Google Cloud services, but you can also enable it for AWS or for some on-prem solutions. So there's an API and SDK that enables you to do that. Essentially, it brings all that logging together and provides a great interface to query that and to diagnose problems. Similarly, there's a monitoring side of Stackdriver. Once again, Google Cloud Platform, but also elsewhere as well. So AWS, we can build alerts based on things like uptime or metrics or whatever log functions we may see. And Cloud IAM provides that security layer. So it enables you to create identity access management. So this is a way of creating users and groups of users within your solution, assigning role-based permissions down to a very granular level, and being able to lock down your services and your systems as you need to. So, okay, so that's great. We've got the Google Cloud Platform. We can do compute. We can build up compute engines, we can do containerization, we can do some serverless type stuff, we've got networking, we can bring everything together. We've got ways of doing big data inside Google Cloud Platform as well. But how do I configure it? So there is a Google Cloud Platform console, which is a browser-based way of getting into and out of and doing things within the cloud platform. But a lot of times, people like using the command line interface. And the command line interface is there. There's a G-Cloud SDK that enables you to interact with the Google Cloud Platform programmatically. So you can write from the command lines. You can write command line scripts, incorporate that into your own scripting shells to perform functions. Similarly, GSU tool is a particular command line interface just for Google Cloud Storage. So it's a way of interacting with Google Cloud Storage buckets, putting data in, getting data out. Doesn't matter if it's a nearline, multi-region, cold line, it's the same interface there. Of course, there's APIs around all our services, which come with the RESTful API, REST endpoints, so you can incorporate that into your own applications programmatically if you need to. Functionally, it's equivalent to the G-Cloud command line interface. So anything you can do in G-Cloud, you can do through the API. And then finally, there's a component called Google Cloud Deployment Manager, which enables you to create configuration files, if you like, using YAML for complex deployments, and then treat that as a system, lock it down if you like, put it into your source systems, and then deploy it across multiple instances. From a development perspective, there's three things here as well. So there's the coding aspect, reporting, and services. So if we look at coding, there's an SDK, and I've mentioned that. So the SDK is around G-Cloud SDK, the Google Cloud Storage SDK, but also if you're doing App Engine, there's another SDK that helps you interact with App Engine a little bit differently as well, App Engine configuration. There are a number of plugins that will plug into the very popular IDEs that are out there in the market, so things like Eclipse, IntelliJ, PowerShell, etc., Visual Studio. And we also have a cloud source repository. So this is where you can actually store your source up in Google Cloud in the Google Cloud source repository. So a lot of aspects there from a development perspective. From a reporting perspective, Stackdriver provides tracing capabilities that either there automatically for some of the services or triggered through the SDK. We have the ability to do error reporting using Stackdriver as well to aggregate those errors, to push them into the logs, or whether it's a log error or an API error, and we can trigger alerts based off that. And of course, some debugging. So you can actually use Stackdriver debugging to step into your code if required, provided it's within one of the supported runtimes on App Engine or Compute. And from a coding perspective, Google's more than just Google Cloud Platform. We've got a lot of services that we provide around Android, around the G Suite tools, around Google+, AdWords, etc., YouTube, and the ability to, hook into those services from applications running on Google Cloud Platform is often important. And within Google Cloud Platform, we have a capability called default credentials. And because this is all within the Google framework, we can use those credentials to access Google services very easily and quickly. So lastly, I'm going to talk a little bit about machine learning. And KJ will be speaking later this week about machine learning in a little bit more detail. But essentially, there's three elements here. So using models, creating models, and then extending models. So from a using models perspective, we've created a number of machine learning models that are available through the Google Cloud Platform. So the Vision API, the Natural Language API, the Speech API, and the Translation API. These are models that we've trained, we've built, but we've made them available publicly through the API. So things like face detection, logo detection, OCR within Vision, things like syntax analysis, entity recognition, or sentiment analysis within NLP. Speech API, being able to convert speech to text in whatever language you're coming in, 80 languages currently supported, and the Translation API to take text from one language into another. So if you haven't started playing with these APIs or exploring them, I encourage you to go and have a look at them. There are some great demos available online. But what happens if your model isn't covered or you want to create a custom model? Well, that's where Cloud ML Engine comes in, which is essentially managed TensorFlow. Of course, what flow, as Terence Ryan would say. So essentially, TensorFlow is an open source machine learning library that has its roots inside Google engineering, once again, and enables you to build your own models and train those models for your own needs. It will take various CPU and GPU type capabilities. You can train models on your laptop, on your own server, or once it gets a little bit too big, maybe your data has increased significantly, you're starting to do some satellite imagery, you might need a higher compute power. And that's really where Cloud ML Engine is positioned. It's about taking your TensorFlow models, enabling them to build at scale, tune, and make them available for use. So as I mentioned, there's a lot of stuff here. Coming back to the first slide, there's a lot of blue hexagons within the Google Cloud Platform. Understanding them can take quite a bit. Becoming an expert in them can take quite a bit of time. The goal here this morning was trying to introduce you to the main ones to start your journey, and kind of build from there. With that in mind, there's a number of tools available to help you on that path. The first one, of course, is to tune in for the rest of the webinar series this week. Go onto Google Cloud Training and see what's available up there. There's lots of tutorials and documentation available. Quick Labs will enable you to do some code labs online, so you can start playing with some of these services and doing some code snippets. Coursera, of course, has some courses around Google Cloud. And of course, contact your local team. Contact me in Sydney, or Hillary in New Zealand, Liam in Sydney. Contact us and we'll come out and have a chat to you about more detailed requirements and how you can actually position your own workloads and start taking advantage of the Google Cloud Platform. If you haven't already, if you go to Google Cloud, cloud.google.com, you can sign up for a free trial. There is a bucket of funds available. I think it's $300 US that you can use over the period to try some of these services out. So I encourage you all to do that. Use it to run some of the code labs. Use it to play with your own workload. You can utilize Google Cloud. So thanks for joining. I think we're going to take a short break between now and when we're answering the questions that you may have generated. So once again, thanks for joining us, and tune in later on for other sessions. So welcome back. Hopefully that break wasn't too long for you and you're still with us. I've got with me now Liam Tong, who works in Sydney with me as part of the professional services organisation, where he's a technical deployment or technical program manager. And Liam and Hilary, who isn't in the room with us at the moment, have been busily taking in your questions, and hopefully we're going to address 4 or 5 of them now. So the first one is question 1. Early on in the presentation, you mentioned regions and zones. What are these? So from a Google perspective, a region is a location for running, that we're providing Google Cloud Platform services. Regions are typically divided up into 1 or more zones, typically 3 zones, but some regions have more or less. And it's a way of segmenting applications and compute down into redundant type units. So when you look at a zone, it's essentially an isolated unit with power and connectivity, so that if a backhoe goes down through one, we've still got another zone running up, and we spread services across zones to provide that redundancy and that high availability. Do you have anything to add there, Liam?
No, that's right. And you would have heard we're opening a number of regions. So you can think of regions as geographic locations which contain a number of zones. For example, we've announced that we're launching a region in Sydney, Australia this year, which will contain 3 zones. So each zone in Google terminology is, as you've alluded to, Mal, a isolated independent network which has independent power from a facility perspective. So they're isolated from each other in terms of technical systems.
And from a deployment perspective, you can elect, if you're building up or instantiating a compute engine instance, you can pick the region you want to have that deployed in, the zone you want to have that deployed in. For some of our services, you can elect, how it splits across zones, etc. You can pick it up from one region and move it to another. So there's tools around to help you with that migrating between zones. So if we don't have a region in your country today, but you want to start playing, you know what? Pick a region in somewhere else, start playing there, start doing your workloads, start exploring the cloud and getting used to it. And when a region becomes available in your time zone or your geographical location, we can talk about migrating that across to make it more closer to home, if you like.
Yeah, that's right. Okay, there's another question here, Mel, about someone who is interested in looking at VMs, moving VMs to GCP. So the question was, my organization currently runs a number of VMs on-premise, but we're keen to move these to GCP and start taking advantage of some of the benefits it provides. Where do I start? How do I work out what to move and when?
So the good news there is that there are tools available to help migrate images or VMs, virtual machines, from wherever they're running today into Google Cloud Platform. So migration tools like Cloud Endure that enables you to even do a live migration. So you can do that migration while that VM's running. You can start doing that migration. It'll start creating the instance up on Google Cloud Platform and migrate that live. Once it's fully there, then there's a period of essentially turning one off and turning on the other and repointing, etc. But it's a reasonably simple process to do that. I guess the more interesting question is, what workloads do I start looking at? And when you look at the VMs or the virtual machines that are running in your environment today, each one of those is going to have different dependencies on applications that are on-premise, perhaps, different requirements around data storage, etc. So the best practice is to look at those workloads, try and work out which ones are low impact, low risk, which ones don't have the dependencies or have a very few dependencies that are more easily migrated to cloud, right? So there's less work to do in that regard on the periphery. And then once you understand what those requirements of each of your workloads are, then you can start putting in, or in triaging that, you can start putting in a plan to migrate over time. Yeah. From a PSO perspective?
I just wanted to add that we also have a lot of partners that focus on GCP migrations. And if you're interested, it's definitely be a good idea to chat to someone from Google or from one of these partners if you're already in touch with them, or someone from Google to get in touch with an appropriate partner for your region and find out how they can help you actually perform this migration. Okay, the third question was around data security. So you talked a bit about this. There's a concern from this person around the organization being concerned about data security in the cloud. If they were to move to a cloud-based solution, how can they ensure that their data is encrypted and all the security considerations?
Okay, so So good news is this week there's a session on securing your workloads in Google Cloud Platform. Look at the agenda, look at the timetable of this week, the schedule for the week, and I encourage whoever asks this question, in fact I encourage all of you to attend that session where it'll probably dive down a lot more detail than I can provide in the next couple of minutes.
It's actually my session, so give myself a plug for that one.
No, that wasn't rehearsed at all.
Yeah,
so
sure.
maybe you can address this question.
Sure, yeah. So on Thursday, I'm talking about securing workloads on Google Cloud Platform. And some of the things we'll talk about are the security designs of Google Cloud Platform from in terms of how a data center is designed, how secure your infrastructure as well as applications on Google Cloud. But if you're interested in how data is encrypted in transit and at rest, there's some good white papers actually out there where you can read up in quite a lot of detail about this, including goes down to some of the algorithms that are used on Google Cloud to secure the data and shard the data.
But the good news is it's encrypted at rest and in transit.
That's right. Yeah.
Using encryption keys that we provide.
That's
or the
correct.
customer provides,
Yeah.
or both.
There's actually a lot of options there.
Right, fantastic. You're going to go into that on your session.
Yeah, we'll talk a bit about that as well.
Excellent. So whoever asked this question, rest assured, data's encrypted at rest and in transit using keys we provide or keys you want to provide. So there's a lot of options there. Last question I think we've got.
Last question is around availability for the VMs that you talked about on Google Compute Engine. Could you tell us a bit more about the availability that's defined there?
Yeah, so once again, so the Compute Engine is essentially an unmanaged service. So you spin up a Compute Engine instance. You're responsible for running whatever software you want to run on top of that. But from an SLA perspective, we provide, I'm trying to read it here, Liam's got it up, I've got my glasses on so I can't really see that. Essentially it's 99.95% uptime, I think, from availability perspective. And then if you go onto the Google Cloud Compute Engine documentation, there's a little table provided that talks about what that SLA is, what happens if we don't meet that SLA, etc. So it has implications from a billing perspective.
That's right.
Yeah.
The other thing I would add is there's some ability to control settings on an instance level or in a group of instances where you can set how an instance should behave during maintenance windows. So there is a feature called live migration, which actually allows Google to do the migration behind the scenes when a maintenance window is happening on an instance. So you effectively reduce the amount of downtime on instances that you have. And Google's kind of doing some magic behind the scenes to migrate those instances automatically.
Great.
All right. I think that's all the questions that we have time for today. So.
Okay, cool. Well, thank you once again for joining us this morning. Hopefully you will sign in for some other sessions later today and later this week. If you've got some friends that missed this session, I'm doing it again later today, so you can tune in for that one as well. Or if you want to hear my voice again before you go off to before you leave work, by all means, join us again. But thank you.
Thanks, guys.